In this video, we're going to take a look at the 5th grade standards for geometry, numbers 3 and 4. The big thing with these two standards is that students should be able to classify two-dimensional figures into categories based on their properties. They're extending their understanding that they've built in 4th grade. G3 asks that students understand that attributes belonging to a category of two-dimensional figures also belong to a subcategory of that category. All that means is that if we are able to classify these two parallelograms because they have 90 degrees, well, we can also go ahead and further subcategorize these two shapes. Here we see that they're both parallelograms with 4 right angles, but we could subcategorize a square by saying that a square has all sides congruent. It's this subcategorization here between a square and a rectangle that allows us to say that all squares are rectangles, but not every rectangle is a square. G4 asks that students classify two-dimensional figures into a hierarchy based on their properties: polygons, triangles, and quadrilaterals. Let's see what this standard actually looks like in a classroom action, as students are using a hierarchy to go ahead and categorize and then subcategorize shapes. In this video here, you're going to see some 5th grade students engaging in the subcategorization of some polygons in a virtual remote setting.
I don't think we need to organize these anymore.
Okay.
And then these ones
Can go sort of at the top. Yeah.
All right, nice. So you took all those shapes, and I see that you sorted them out. How did you sort them out? How did you sort them out? What are you thinking?
We sorted them out by how many sides they had. So either a quadrilateral, or if it had 4 sides, 5 sides, 6 sides, or 3 sides.
All right, so I'm going to take all of these shapes right now. I'm going to take all of these shapes. So just hang on one sec. And you said all of these shapes that I'm clicking on right now, they're all called what? Quadrilaterals. Okay, what I'd like for you to do right now is I want for you to go ahead and sort all these quadrilaterals. How could you do that, Audrey? What are you thinking? How could you do that? You two talk about it. What we did was we sorted them all by sides, but what if we say, like, you can't sort these by sides anymore? Why can't you do that, Audrey?
Because they all have 4 sides and 4 vertices.
Okay, so you've got to figure out something else now. Go ahead.
Bella, I was thinking maybe we could do how many sets of parallel lines they had.
That's what I was thinking. But some of them don't have any parallel lines.
Well, we could do 0 parallel lines, 1 parallel line, or 2 parallel lines.
Okay.
Two parallel lines.
All right. So it looks like you're done here. So Bella, how did you sort them this time?
This time we sorted them by how many pairs of parallel lines they have. On the right we have 1 pair of parallel lines.
Over here, okay.
In the middle we have 0 pairs of parallel lines. And on the left we have 2 sets of parallel lines.
All right, nice. Okay, so here's my next question for you. I'm going to go ahead and take all of these here. And Audrey, what was this group here that I'm copying right now?
That was 2 pair of parallel lines.
All right, perfect. I want you to sort the 2 pairs of parallel lines out now.
Here.
So what makes it a square? So like if I take, so what you're telling me then is if I take this piece and I put it to where it's on flat on its side, like this is now a square?
Yes, sir. It was just, you just have to basically it's like a laying down square. So it's flat on the ground. And then the square that most people would say that's the only square, the one at the top.
Okay. Bella, did you have something to say here?
I was going to say, for a square to be considered a square, all of 4 sides must be congruent and all of them must have 90-degree angles.
As the students worked through that hierarchy of shapes, you could see that there were some misconceptions that came to the forefront. And what's great is that we're catching this at the beginning part of a unit because we're using this task as formative assessment to see where student thinking is in that progression of learning. So as students were playing around with these shapes, they began by sorting them into polygons. And as they had the polygons, they went ahead and subcategorized those polygons into triangles, quadrilaterals, and then also shapes with 5 and 6 sides. And then after they sorted them into quadrilaterals, we had them subcategorize their quadrilaterals, and they just chose to define it by parallel lines. As students defined it into parallel lines, they needed another way to subcategorize those quadrilaterals with parallel lines, and they did so by sorting them through number of congruent sides and angles. It's activities like this that allow our students to dive into these 2 geometry standards. Here in this example that we just played around with classroom action, students were using quadrilaterals, but the same understanding can be applied to triangles as students can begin to subdivide and subcategorize those triangles. Here we can take these triangles and classify them by sides and side lengths, isosceles, scalene, equilateral. Or we could take our triangles and we could classify them by angles, acute, right, and obtuse. Students should have opportunities to play around with a variety of shapes and undoing categories and putting categories back together. That's what these 2 geometry standards are all about.